Okay, let's see. Number 12. Kirlian photography apparatus. A fingertip hovers over glass in a dark room. Beneath it, a metal plate hums with high-frequency current. The switch snaps. Air ionizes. Suddenly the skin seems to bloom, blue-white fire fringing every ridge, as if the body is leaking light. In 1939, in Krasnodar, Semyon and Valentina Kirlian turned that eerie accident into an apparatus. Film, insulation, an electrode, and anywhere from 4,000 to 50,000 volts. Press a leaf, a coin, a finger against it, and the invisible seems to answer back. To some, this was proof of an aura, a hidden anatomy waiting just beyond normal sight. To others, it was corona discharge, moisture, pressure, conductivity, air chemistry dressed up as revelation. The split began there. A machine appeared to uncover something unseen, and the meaning of what it showed broke in two. The room stays dark. You can smell warm dust and varnish. Somewhere inside the housing, the transformer keeps up a thin electrical whine, high and steady, like an insect trapped behind the wall. Semyon Kirlian leans over the workbench. One hand rests on the casing of the electrotherapy device he has been repairing. The other hangs near the electrode, because near is safer than touching when the machine is built to throw high-frequency current through metal. Valentina stands close enough to see the plate, not close enough to trust it. On the bench, the setup is almost plain. A discharge plate, a layer of glass for insulation, photographic film, wire, clips, darkness. The darkness does half the work. In the dark, even a tiny corona looks impossible. He brings his hand near the sparking electrode, and something answers. Not a flame, not contact, a fringe. A cold-looking glow rides the outline of the skin and flickers at the edges where the field is strongest. For a second, it is gone. Then it returns when he changes the spacing. Valentina sees it too. That matters. Strange light is easy to dismiss when you are alone with bad wiring. It is harder when someone else catches the same blue-white rim around a living hand. So they stop repairing and start arranging. The object goes on the plate first, a finger, pressed down carefully, then the insulating layer, then the film, close enough to receive whatever the air is doing when the current builds. There is no lens, no ordinary camera body aimed across a room. This is a contact print made by pressure, electricity, and the chemistry of emulsion. Semyon adjusts the source. Machines of this type can run anywhere from 8,000 to 50,000 volts, at frequencies from 100 to 10,000 hertz. The current is kept low. High voltage with low current can still be handled if you know exactly where your hands are and exactly where they are not. He lowers the lights further. The switch closes. The plate answers with a crackle. It is too small to hear over the transformer and too sharp to miss once you know it is there. Around the finger, the air ionizes. Tiny streamers leap from ridge to ridge. Sweat pores become bright points. Moisture thins and thickens the halo. Pressure changes it. The angle of the nail changes it. The film waits under all of this, blind until development, while the skin above it seems to wear a second skin made of sparks. When the exposure ends, he lifts the hand away. Nothing dramatic remains on the glass, just the plate, the film. The ordinary bench again. This machine keeps its truth hidden until the chemicals do their work, so the suspense moves to the tray. Developer first, then agitation, then waiting. Valentina watches the image swim up from blankness like a shoreline through fog. It is not a fingerprint in the usual sense. It is stranger than that. Every ridge is picked out by a corona of light. The outline is so precise it looks anatomical, and so unstable it looks alive. Now they try a leaf. The leaf lies flat, its veins pressed near the surface. The current hits the metal plate under the glass. The field rises through the insulation. The edges of the leaf glow hardest where the geometry sharpens into points. If a finger looked ghostly, the leaf looks surgical, every tooth and curve written in white fire. They expose another plate, then another. A coin next. Hard metal gives a different kind of edge, cleaner and less feathery, because metal conducts one way, plant tissue another, skin another still. The machine teaches this in silence. The image changes with the thing on the plate. It also changes with conditions no eye can track in real time. Humidity in the room, pressure of the hand, residue on the glass, the exact voltage, the exact frequency. The hidden world is there, but it is built from variables that refuse to sit still. That makes the effect more seductive, not less. You stand there in the dark and watch images emerge that seem to show more than shape. A normal photograph gives you a leaf. This gives you a leaf wrapped in radiance. A normal print gives you a finger. This gives you a finger with weather around it. If you wanted to believe the body had an invisible envelope, the apparatus would meet you halfway. It would not need to lie. It would only need to glow. So the experiments multiply. Semyon and Valentina refine the setup into an apparatus simple enough to repeat and strange enough to keep pulling them back. Glass, electrode, film, high-frequency current, object, darkness, exposure, development. The sequence becomes routine. The results never do. Every fresh plate promises a hidden signature. Every altered fringe looks like a clue. By 1949, the work is formalized into Soviet patent number 106401, a method for receiving photographic pictures of objects by means of high-frequency currents. By 1961, the Kirlians published their paper in a Soviet photography journal. On the page, it is a technical procedure. In the tray, under safe light, it still feels like conjuring. Years pass. The apparatus changes hands, rooms, and stories. In 1970, Psychic Discoveries Behind the Iron Curtain carries it westward. The same blue fringes that rose over a workbench in Krasnodar are treated as evidence that the body has a hidden double. At UCLA, Thelma Moss will look into these images and see auras, subtle bodies, a secret anatomy waiting in the glow. Here, in this room, before the claims harden and the arguments split, the machine is doing exactly what it did on the first day. It makes air break down around an object. It forces film to record the event. Semyon places another leaf on the glass. He exposes it. He removes it. Then, with scissors, part of the leaf is cut away. The missing section drops aside. The remaining piece goes back onto the plate in almost the same place as before. Another exposure, another tray, another image lifts out of chemistry. For a moment, the absent piece seems to be there. Not solid, not green, not real. A faint continuation at the torn edge. A suggestion that the vanished part has left behind a luminous after-image. If you saw only that plate, you would think the machine had photographed what was no longer present. A phantom leaf. Proof, maybe, that living things carry a field extending beyond the body itself. But the plate was not empty. It was dirty. Number 11. AuraCam 6000. On January 15, 1997, inventor George Coggins filed U.S. Patent 5792047. Its calm, technical title was Physiological Parameter Monitoring and Biofeedback Apparatus. No spirits, no halos, no hidden bodies. Just a system for reading the human surface through numbers, skin resistance, temperature, pulse, galvanic response, and turning those signals into feedback a person could see. The patent was published on August 11, 1998. It looked like wellness hardware. By the summer of 1999, at a lakeside psychic fair in western New York, the same logic had been repackaged into something more seductive. A machine that could show you the aura around your body. One man sat down to see whether it could. On July 17, 1999, investigator Joe Nickel took a seat at the AuraCam 6000 booth at a psychic fair in Olcott Beach. The setup was simple, and that simplicity was the genius of it. You place your hands on wired electrical modules. A camera points at your face. A small printer waits nearby. $20 later, the unseen is supposed to become visible. That temptation runs through this whole story. Not just detecting what eyes miss, but giving the invisible a face, a border, a printout you can carry home. Nickel was not there for comfort. He was there to test the claim. He followed the ritual exactly. Hands on the sensors, portrait taken. Then the machine did what made the performance feel scientific. It did not only spit out a picture, it produced two forms of evidence at once, a Polaroid portrait and a printed color map. The result looked measured, processed, and verified by electronics before any human interpretation touched it. The first result was dramatic. A strong, yellow-white burst flooded the image so brightly it nearly washed out Nickel's face. The overexposure was not treated as a flaw. It was treated as a reading. The aura reader called the brightness a sign of spiritual intensity, a kind of luminous surplus. Nickel had paid for a picture, but he was being sold an explanation. Color became character. brightness became biography. The machine delivered an image, and the human translator told you what it meant. Nickel did not leave. He came back minutes later for a second test. This time, he changed one variable the operator had suggested might matter: his thoughts. If mood and inner state really shifted the aura, the next image should change in a meaningful, predictable way. He sat down again. Another $20. Another set of hands on the wired modules. Another portrait. This was the moment the machine had to show it could distinguish one invisible condition from another. It did change, but not in the way a believer would want. Instead of producing the predicted red, tied to a different emotional state, the second image came back mainly blue and green. The explanation changed with it. Now the colors were said to reflect calmness, balance, even teaching energy. The machine had not corrected the interpretation. It had made room for a new one. The colors shifted. The story shifted. Both arrived with the same confidence. The AuraCam 6000 was never strongest as a camera. It was strongest as a ritual. About 2 seconds captured the portrait itself. Then, a 6 to 8 second color overlay was added in a double exposure, wrapping the face in bands of tinted light. Depending on the setup, it used film stocks like Fuji FP100C, Polaroid 108, or Polaroid 669. To the customer, it looked like revelation in real time. But the revelation was assembled from pieces: a face, sensor input, programmed color choices, and a live reader ready to turn any result into a personal truth. Here the patent matters more than the booth. Strip away the mystical language, and the hidden engine looks much closer to biofeedback than photography. The hand sensors do not reach into a secret field floating 6 inches off your skin. They monitor ordinary physiological parameters: electrical resistance, heat, pulse-related variation, and feed those into a system that assigns color values. Even Coggins clarified that the AuraCam does not photograph an actual aura. It visualizes sensor-derived data as color. That is a very different claim. One says the camera discovers something already there. The other says the machine creates a representation from indirect measurements. At a fair table, under soft lighting, with a Polaroid developing in your hand, that distinction almost disappears. You are not reading a patent. You are looking at your own face, ringed in blue, green, violet, gold. Someone across the table is telling you this haze is you, only more so. More intimate than a snapshot, more truthful than expression. Because the output arrives through wires, electronics, and a printed chart. It borrows the authority of instruments without accepting the burden instruments usually carry: repeatability. Nickel understood that. His test was devastating because it was so small. He did not need to dismantle the machine. He did not need access to its internal circuitry. He only needed 2 sittings separated by minutes, one suggestion about mood, and the patience to watch whether the system held steady. It did not. The readings changed sharply. The interpretations stayed elastic enough to absorb whatever appeared. In other words, the machine could not be trapped by contradiction, because contradiction was part of the business model. If yellow-white meant spiritual brightness the first time, blue-green could mean serenity the second. The customer still left with a revelation. This is where the device fits into the history of forbidden or vanished ways of seeing. Not because it opened a window into an invisible anatomy, but because it showed how easily technical language can launder belief. A generation takes years to learn what sensors really measure, what images really encode, how instruments really fail. A market can reverse that education in an afternoon by turning data into theater. The knowledge does not have to be destroyed. It only has to be reframed until the public can no longer tell the difference between detection and decoration. By the 2000s, an AuraCam 6000 could sell new for around $10,000, not novelty store junk. A serious-looking machine for producing serious-looking evidence. The lesson in Olcott Beach was bigger than one fairground reading. Nickel walked up to a device marketed as a way to see the unseen. What he found was more durable. A system that transformed fluctuating body signals, colored light, and flexible interpretation into apparent proof. It did not reveal an aura. It manufactured one. Then asked the customer to mistake that manufacture for discovery. Nickel's verdict was blunt. The results were inconsistent and subjective. Number 10. William Mumler Spirit Photography Camera. In November 1862, in Boston, William H. Mumler sat for a self-portrait in his studio and came back with an extra person in the frame. Mumler was not a medium by trade. He was a jewelry engraver, born in 1832, and an amateur photographer working with the same new visual machinery that was teaching Americans to trust what a plate could hold. Plain backdrop, seated subject, glass negative, album in silver print. Behind him, faint and pale, stood a woman-shaped figure he identified as a cousin dead for about 12 years. The image was published in the spiritualist paper Banner of Light. Overnight, an ordinary studio camera started to look like something else entirely, a device that could turn bereavement into evidence. That claim mattered because photography in the 1860s did not feel routine. It felt authoritative. A painted portrait could flatter. A witness could lie. A camera was supposed to catch what was there. So when Mumler began selling portraits in which translucent spirits hovered behind grieving sitters, he was offering more than comfort. He was taking one of the century's most trusted machines and using it to suggest that it had captured a second world. By the late 1860s, clients were coming to him for exactly that. Sit in the chair, hold still, wait through the exposure, then watch the dead arrive in chemicals and light. In surviving examples dated roughly 1862 to 1875, men and women sit rigidly in the foreground, while misty faces, draped bodies, or half-formed companions gather behind them. One picture in the Met's collection shows an unidentified seated man attended by 3 spirits. They are arranged with just enough softness to feel otherworldly, and just enough detail to feel real. That balance was the trick. Too sharp, and the spirit looked staged. Too vague, and the customer had paid for fog. The camera itself was never exotic. There was no secret lens from a monastery, no forbidden mineral, no coils, rays, or hidden chambers that scientists could not explain. The material record points to ordinary photographic practice. Glass negatives, album in silver prints, a standard studio workflow. The scandal was simpler and stranger. Mumler seemed to use a normal evidentiary machine to produce impossible evidence. So start with the mechanics, not the seance, the plate. A spirit photograph only needs 2 things, an image of the sitter and an image that should not be there. In court, experts would later argue that there were multiple ways to make that happen. Guinness notes 9 methods were proposed in the 1869 proceedings for producing ghostly effects. 9. That number matters. Investigators were not facing a miracle. They were facing a menu of darkroom and plate tricks already available inside 19th century photography. A reused glass negative not fully cleaned, a faint prior exposure, a composite, a second printing image carried over where it should not survive. Double exposure is the explanation most people know now, but the hearing made something more unsettling clear. The exact method remained slippery because several methods could produce the same visual result. That is where the case gets difficult. Fraud usually weakens once you identify the mechanism. Mumler's case did not. The mechanism lived inside ordinary practice. If a fake medium hides wires, you show the wires. If a fake photographer works with exposures, plates, and developing steps that every professional already uses, the fraud is harder to pin down. You may know the apparition was manufactured. You may even know roughly how. Proving which plate, which moment, which manipulation, in which sitting, is another matter. Suspicion followed him anyway. One spirit was recognized as a living person. Rival photographers were furious. P.T. Barnum, who understood staged wonder better than almost anyone in America, turned against him. Spiritualists defended him because Mumler's pictures seemed to do what sermons and seances only promised. Then, after moving to New York, Mumler was arrested in 1869 and brought before Justice Joseph Dowling over fraudulent spirit photographs. The hearing became a slow forensic grind. Elbridge T. Gerry argued the case on May 3, 1869. Testimony and arguments stretched for 7 days. Not 7 minutes of ridicule, 7 days. Long enough for photographers to walk the court through process, plates, exposures, printing, and contamination. Long enough for the prosecution to say, these ghosts are not visitations, they are artifacts. Long enough for defenders to answer that no one had actually caught Mumler performing the trick in a way a court could nail down. That difference decided everything. Publicly, the issue was whether the dead could be photographed. Legally, the issue was narrower and much colder. Could anyone prove exactly how Mumler cheated a paying sitter in a specific instance? The answer was no. Justice Dowling dismissed the case for lack of proof, not for lack of doubt. for lack of proof. So the myth survived the one place it should have died. Then it reached the White House's shadow. In 1872, Mary Todd Lincoln came to Mumler's Boston studio, veiled and under an assumed name. 7 years had passed since Abraham Lincoln was shot. The country had buried a president, but she had buried a husband. She sat for the portrait. When the print came back, the ghost of Abraham Lincoln appeared standing behind her, his hands near her shoulders, protective and unmistakable. It became one of the most famous spirit photographs ever made. Look at what that required. Not a machine capable of detecting souls, a machine capable of exploiting recognition. The apparition did not need to move. It did not need to speak. It only had to resemble the dead strongly enough that grief would complete the image. Mumler borrowed the visual prestige of photography and let the sitter supply the final certainty. The pattern runs straight through the whole story. Hard-won knowledge does not always vanish when the tools disappear. Sometimes it vanishes when the public forgets what a trusted tool actually measures. A camera records light, that is all. In Mumler's studio, light was arranged until it looked like memory had become fact. One technical question still refused to die. Which exact trick did he use? Court experts could demonstrate similar effects. Critics could point to likely methods. Historians today can say multiple exposure and darkroom manipulation are the best explanations. But the record never closes all the way. The specific process behind a given Mumler plate remains uncertain because uncertainty was built into the workflow. The same blur that made the spirit believable also made the fraud hard to isolate. Mumler's camera belongs in this list because it weaponized the authority of a familiar technology. The apparatus was ordinary, the claim was not. Once that claim attached itself to mourning, the evidence did not need to be perfect. It only needed to arrive in a form people had been trained to trust. Later, in a final twist almost too neat to be real, Mumler would be associated with a photographic reproduction method used in newsprint, part of the machinery of mass visual journalism itself. The alleged ghost maker, drifting toward the world that taught millions to treat printed images as proof. Stay in the studio for one more second. Mary Lincoln is still seated. The plate has been exposed. In the developing image, a dead president begins to emerge behind her shoulders. No one in the room can yet prove where he came from. Number 9. Drown Radio Vision Camera. On May 23, 1963, Jackie Metcalf walked into Ruth B. Drown's office on La Brea Avenue in Los Angeles, carrying 3 pieces of stained blotting paper. Metcalf was 22 years old, a housewife from Torrance, and she came in as a worried mother. Inside the room, the price was simple. $50 per diagnosis, 3 samples, $150 total. The samples, she said, contained blood from her children. Days later, Cynthia Chatfield, Drown's daughter, delivered the verdict. Chickenpox, mumps. Treatment instructions followed. To begin therapy, Metcalf was told she would need a Drown therapeutic instrument, priced at $588. Drown's system rested on a single claim. A drop of blood was enough. Dry it on paper. Mail it across a city, across a country, across the Atlantic. Put that sample into the instrument, and the body it came from stayed linked through what Drown called vibration. Not metaphorical vibration, operational vibration, a live connection at a distance. By that logic, she could diagnose disease from the sample, then send corrective frequencies back along the same link once the machine was tuned to the patient's rate. The radiovision camera carried that claim further. If a blood spot could stand in for the whole body, then the body did not need to be present for imaging either. In Drown's published claims and later testimony, the camera could produce photographs of hidden anatomy from that remote sample alone. Organs, tumors, blood clots, even foreign objects left inside a patient after surgery. The promise was literal. A camera without reflected light from the subject. A diagnosis without tissue under a microscope. A photograph without the person in front of the lens. A normal camera follows a basic chain. Light from an object, a lens, a photosensitive surface, exposure time, development. Drown's camera removed the first step. No direct light from the organ to the plate. The blood sample was supposed to carry the body's vibratory identity instead. Tune the instrument correctly, and the machine would turn that identity into an image. In 1939, the claim became formal enough to enter patent paperwork. British patent GB 515866 was accepted on December 15, 1939, under the title Method and Means for Obtaining Photographic Images of Living and Other Objects. That matters because people hear the word patent and think proof. They hear a filing date, an acceptance number, and the claim suddenly sounds reinforced. A patent office measures one thing, a medical test measures another. So look at December 31st, 1949, University of Chicago, controlled conditions. Drown was given dried blood samples and asked to diagnose the people they came from. Her entire system should have welcomed a test like that. No hostile philosophy, no impossible demand. Names hidden, samples presented, results compared. She failed badly. Later court records describe a radical miss, not a close call, not a disputed interpretation, a collapse under conditions designed to strip away suggestion and luck. After that, the story moved out of mystique and into federal court. On September 10, 1952, the Ninth Circuit affirmed Drown's conviction involving a misbranded device. In court, one of the quiet blows was not only that the medical claims failed. Experts who took the machines apart described circuitry far simpler than the language built around them. Beneath the dials and terminology, the devices were said to amount essentially to two dissimilar metals, a wire and a meter. That detail changes the whole scene. If the controls do not materially alter the circuit, then much of the complexity the customer pays for may be theater. And the theater cost money. $50 per diagnosis in 1963 was not pocket change. Metcalf paid for 3. Then came the $588 therapeutic box. Scale that outward, and the numbers widen fast. By the time of the arrests, Drown and Chatfield treated about 35,000 people. Even if those cases varied in fee and service, the size of the operation shows this was not a fringe machine collecting dust in one back room. It was a working system with customers, revenue, repeat procedures, and an audience already trained to believe that hidden disease could be seen and corrected through a sample no larger than a stain. Now go back to Metcalf. Investigators understood something crucial. If the machine really read invisible truths from blood, species should matter. Human blood should not read like barnyard blood. So they set a trap with 3 animals, a turkey, a sheep, and a pig. Drown's office accepted all 3 as children. Then Chatfield diagnosed childhood illnesses in them. Chickenpox, mumps, diseases assigned not just to the wrong patient, but to the wrong species. This was not a small error at the edge of a new science. The whole floor gave way. You can watch the logic collapse in reverse. First premise, the sample carries the patient's unique signal, but the turkey passes for a child. Second premise, the machine distinguishes disease states through hidden vibratory patterns, but the pig develops mumps on schedule. Third premise, treatment can be tuned precisely enough to correct those states at a distance. So the $588 box is not targeting a body, it is targeting belief. That loops back to the question running under this whole list. Why does hard-won knowledge that took generations to master vanish without a trace? And who benefits when it does? Sometimes it disappears because people stop remembering what a real instrument is supposed to prove. A medical image is not powerful because it looks secret. It is powerful because the chain from body to signal to record can be checked. Break that chain, and the picture becomes a performance in the costume of evidence. Drown understood the value of that costume. The radiovision camera was more than another diagnostic gadget. It offered visual authority. Hand someone a photograph said to show a hidden tumor, and the argument shrinks fast. The image did what the jargon alone could not. It made the invisible feel audited. Officially, that world ended in raids, failed tests, and appellate decisions. Officially, the camera was filed away in the history of medical fraud and useless devices. But the paper trail remained. A patent number from 1939. A machine with dials. The intoxicating idea that the body could be photographed from a blood spot alone. That was enough to keep the myth alive. The device never had to see through flesh. It only had to look like proof. Number 8. Hieronymus Machine. In June 1956, a reader opened Astounding Science Fiction to pages 97 through 108 and found John W. Campbell, Jr. calmly proposing a machine that might let a person detect what no ordinary sense could reach. Not with a camera, not with a Geiger click, with a hand. A sample goes near a coil. The signal passes through wires, a prism or lens, adjustable electrodes, capacitors, an amplifier. Then the chain ends under your fingers on a smooth plate. You stroke it lightly until, at one setting, it turns tacky, sticky. That drag is the answer. If true, the consequences are simple. A hidden property of matter would no longer need to become light or sound or a needle on a scale. It would go straight into the operator's nervous system. A trained hand becomes the final instrument. And years after patents and lab benches were supposed to make older, magical thinking obsolete, the line between machine and medium would have quietly given way. Campbell did not invent the device. The paper trail starts a decade earlier in Kansas City, Missouri, with electrical engineer Thomas G. Hieronymus. On October 23, 1946, he filed a patent for an apparatus with a long, careful title: Detection of Emanations from Materials and Measurement of the Volumes thereof. 3 years later, on September 27, 1949, it was granted as U.S. Patent number 2,482,773. 13 claims, a real patent number, a real inventor. That matters because patents do something socially powerful, even when they prove almost nothing scientifically. They make an idea look as if it has crossed a border from hunch into hardware. The machine itself was oddly concrete. The patent did not describe incense and symbols. It listed parts: a pickup coil about 2 inches in diameter, or a cylindrical coil wound around a core roughly 1 inch across. A sample placed near that coil. Conductors carrying the supposed emanation onward. Optical elements. Electrodes set about 1/2 inch to 2 inches from the prism in working use. Capacitors. An amplifier. Sample temperatures around 40 to 90 degrees Fahrenheit, though the document said that was not critical. Read line by line, it sounds less like a seance than a benchtop instrument assembled by someone who knew exactly how official language should feel. The detector was the strangest part. Not a dial, not a chart recorder, not a photographic plate. The operator rubbed a touch surface and judged a change in friction when tuning reached a peak. The body was not merely using the machine. The body was inside the measuring chain. That is where everything turns. A device that claims to convert hidden signals into a sensation only a human can feel strips away the usual safeguards. There is no permanent trace on paper. No independent readout to compare later. No clean separation between source, instrument, and interpreter. The machine asks for more than observation. It asks the operator to trust their own skin. That detail is not small. It is the whole consequence. Suppose the signal were real. Suppose matter truly emitted some invisible signature that this apparatus could isolate. Then a trained person could sort materials, detect substances, maybe identify hidden differences that ordinary optics and electronics miss. No visible image needed. No agreement needed about what the signal looked like on a meter, because the decisive event happens in the fingertips. Detection becomes intimate, portable, deniable. A laboratory could claim a discovery without producing a conventional trace. A government office, a prospector, a salesman, a crank, all could point to the same polished plate and say the machine works if the hand is educated enough. The old question underneath this video sharpens here. When knowledge vanishes, sometimes it is not buried. Sometimes it is rerouted into forms that cannot be audited. Hieronymus, to his credit, did not seem to want that story told as magic. He called the supposed phenomenon eloptic energy and treated it as physical, however implausible that sounds. He wanted the machine taken seriously as an apparatus detecting an unknown emanation from matter. In 1956, Campbell pulled it somewhere else. Campbell was not just any enthusiast. He was the editor of Astounding, one of the central gatekeepers of science fiction in the United States, with a gift for making fringe ideas feel one breakthrough away from history. When he published Psionic Machine, Type 1, he reframed the device as something closer to machine-assisted psychic perception. That shift mattered more than the circuitry. Once Campbell pushed the idea towards psionics, the Hieronymus machine stopped looking like a disputed instrument and started looking like a technological permission slip for ESP. Campbell went further and claimed symbolic analogs could work too. Paper and ink circuits, drawn components standing in for physical ones. At that point, the machine was no longer only detecting an invisible property of matter. It was drifting into a universe where representation itself might be enough. A sketch could behave like hardware. A diagram could stand in for a circuit. The performance slipped one layer deeper. You no longer needed a black box with wires if the idea of the box might do. Hieronymus later objected that this magic framing ruined the invention's chance of being taken seriously. You can see why. There is a world of difference between saying, "I have discovered an unknown physical radiation," and saying, "Symbols on paper may extend psychic sensing." The first invites difficult tests. The second dissolves when tests arrive. If the result fails, the operator was tired. The tuning was off. The symbolic arrangement was wrong. The gifted person was absent. The claim can always retreat faster than evidence can catch it. Years later, what remains is a machine with a patent number, a magazine article, a cluster of secondary accounts, and one glaring hole in the record. No robust, independent, blinded validation showing that the device could identify materials above chance without operator cueing. That silence is not a footnote. It sits at the center of the story. The Hieronymus machine promised to reveal the unseen, but it placed the final proof inside a human sensation that left almost nothing behind. No image, no spike on a graph, no record except the operator saying, "There, that's it, I can feel it now." That is how an invention can survive failure. It does not have to produce a stable result. It only has to preserve the posture of one. A patent in 1949, a famous editor in 1956, a smooth touch plate waiting for the hand. In the quiet version of this story, the machine does not glow or spark or expose some hidden world. It sits on a bench, tuned to a signal no one can separate from the person touching it. Number 7. Shoe-fitting fluoroscope. In 1957, a case report in the British Medical Journal described a woman in Copenhagen with severe pain and damaged skin on her right leg and foot. The doctor, H. Kopp, saw what looked like classic X-ray dermatitis. That usually pointed to a familiar source: hospital treatment, repeated imaging, some known medical exposure. But the patient said no. She had never received radiation therapy to that area. She had not even had an X-ray examination of the injured leg and foot. So, Kopp traced the exposure backward. The trail did not end at a clinic. It ended in a shoe shop. For about 10 years, this woman had worked beside a shoe-fitting fluoroscope, operating it roughly 15 to 20 times a day. That number matters. A fluoroscope was not a passive display case or a measuring stick with a light bulb inside. It was a retail X-ray machine. The customer stood on a platform. The parent bent toward one viewing port. The clerk leaned into another. Sometimes a third port let the child look too. Inside the cabinet, beneath the shoes, an X-ray tube sent radiation up through leather, flesh, and bone, so everyone could admire the fit in glowing outline. It looked scientific. It looked modern. It looked honest. That was the selling point. The document gives enough detail to picture the scene. One detail breaks the cheerful showroom image. If this was only a quick retail check, why does the injury look like occupational exposure? Why is the harmed person not the occasional customer, but the worker standing there every day? Because the shoe-fitting fluoroscope did more than measure. It manufactured trust. The paper trail begins on February 6, 1919, when Dr. Jacob J. Lowe filed a U.S. patent application for a shoe fluoroscope. On January 18, 1927, Patent US 1614988A was granted and assigned to the Adrian Corporation of Milwaukee. Rival claims later appeared about the machine's true inventor, with names like Matthew B. Adrian and Clarence Carrer surfacing through testimony and recollection. But the patent record is clear on one point. This device was built to make the unseen visible at the exact moment money changed hands. Not in a hospital, in a store. The design gives it away. Typical machines operated around 50 kilovolts and 3 to 8 milliamps. Between the X-ray tube and the customer's feet, the standard description listed just 1 millimeter of aluminum filtration. The timer often ran from 5 to 45 seconds, with 20 seconds a common setting. 20 seconds is long enough for a child to stand still, long enough for a parent to feel reassured, long enough for a salesman to close a sale. It is also long enough for repeated exposure to stop being trivial, especially when the same cabinet runs all day and the same clerk never really leaves its side. The sales pitch blurred that part. The machine let 3 people see the same bone at once: the child, the parent, the clerk. Proof shared in real time. No need to trust the salesman's fingers. No need to trust the child saying, "It feels fine." No need to trust the parent guessing how much room to leave at the toe. The fluoroscope turned uncertainty into a little performance. Once a machine can stage certainty in public, arguing with it gets much harder. By the early 1950s, there were an estimated 10,000 of these machines operating in the United States, about 3,000 in the United Kingdom, and around 1,000 in Canada. Scale changes the picture. One dangerous machine is a mistake, 10,000 is a culture. Children climbed onto these boxes during ordinary shopping trips. Clerks stood beside them through entire shifts. Some workers even put their hands into the beam to press the shoe and judge the fit while the image was live. The most exposed person in the room was often not the customer who came once. It was the employee who came 6 days a week. When investigators finally measured the output, the numbers turned ugly fast. In 1949, exposure measurements reported by Williams ranged from 0.5 to 5.8 Röntgens per second to the feet. Per second. Not per session. Not per day. Per second. At the high end, a 20-second exposure was not some harmless peek through leather. It was a burst. Go back to Kopp's patient in Copenhagen. For 10 years, she works beside the cabinet. 15 to 20 operations a day. The machine is familiar now. Routine. Almost like furniture. A child steps up. A parent leans in. The clerk works the machine again. Customers stay calm because it looks official. Management stays calm because it helps sell shoes. The worker stays calm because nothing hurts in the moment. Radiation does not need drama. It can wait. That is what makes the report land so hard in the middle of the century. The harm becomes visible only after years of accumulation. The cabinet in the store and the lesion on the leg do not look related. One belongs to commerce. The other belongs to medicine. Kopp's report forces them into the same frame. After that, the invention reads differently, not as a marvel of modern fitting, but as evidence. The larger pattern comes into focus here. Some forbidden inventions disappeared because they failed to produce anything reliable. This one did exactly what it promised. You really could see the unseen. Bones glowed. Toes appeared inside leather. The image was real. That made the danger harder to challenge. The machine earned trust in public while the damage built in private. Hard-won knowledge does not always vanish. Sometimes it gets buried under a smoother sail. By 1957, the same year Kopp's case appeared, Pennsylvania became the first U.S. jurisdiction to ban shoe-fitting fluoroscopes. Other bans and removals followed. The magical showroom box, once sold as proof that the shoe fit correctly, had become proof of something else entirely, an injury report from a shoe store. Number 6. Wilson Cloud Chamber, September 1894. You're on Ben Nevis in Scotland, above the clouds, where Charles Thomson Rees Wilson is serving as a relief observer at the Mountain Observatory. The air is cold. Mist shifts below your feet. A shadow falls across it, and around that shadow sits a bright ring, a glory, a halo hanging in vapor like the sky has started sketching with light. Wilson is not looking for a weapon or a physics instrument. He is watching weather do something beautiful, and he wants to trap it in glass. A lot of machines in this story were built to hunt what nobody could see. Wilson's was not. He began with wonder. He wanted to copy a cloud. So in early 1895, back at the Cavendish Laboratory in Cambridge, he starts expanding moist, dust-free air inside a sealed vessel. The idea is simple. Cool the air fast enough, and vapor should condense. Build a private little cloud on command. But the chamber keeps doing something stranger than the mountain did. Tiny droplets appear again and again, even when the air has been cleaned. No dust, no smoke. No obvious seeds for the water to gather on. Still, the cloud comes back. The experiment refuses to stay inside the reason he built it. Wilson starts to suspect the droplets are forming on something invisible. Ions, charged bits in the air. Too small to see, too real to ignore. So the machine shifts, almost by accident, from imitation to detection. He is not trying to see radiation. The vapor keeps pointing to something his eyes cannot catch. Then the timing turns perfect. At the end of 1895, X-rays are discovered. Suddenly, physicists have a new, invisible disturbance to work with. In early 1896, Wilson exposes his primitive chamber to X-rays, and the effect is immediate. Heavy condensation, more droplets, more cloud. The sealed vessel reacts as if the air has filled with hooks. In a way, it has. The radiation knocks electrons loose and creates ions, and the vapor latches onto them. A weather experiment becomes a detector, not a meter with a needle, not a crackle in a speaker, not a theory in a notebook, a chamber where the unseen leaves a physical trace in wet air. You do not measure the thing directly, you watch what it does to a cloud. Before this, radiation could be inferred. After this, it could be watched. That sounds small. It is not. Once knowledge gets an image, it gets harder to dismiss and easier to spread. It no longer belongs only to specialists with instruments and equations. A photograph can carry it. But Wilson still does not have the form that will make the machine famous. Not yet. For years, the idea sits there and gets sharper, cleaner, more controlled. The principle stays the same, but the timing improves. The build improves. He learns how to make vapor reveal a passing charge before the trace collapses back into nothing. Then in 1911, he gets there. Wilson constructs the cloud chamber that makes the paths of ionizing particles visible and photographable. Early that year, he sees and photographs individual alpha and beta particles. A particle crosses the chamber. It ionizes molecules along its path. Supersaturated vapor condenses on those ions. For a brief moment, the track appears as a thin white line, a tiny scratch of cloud in open space. You are looking at the footprint of something that should have passed without witness. This is why the invention lands differently from the fluoroscope. The shoe-fitting X-ray cabinet let ordinary people see inside the body, yes, but only by flooding the scene with radiation and trusting a glowing display. Wilson's chamber does something subtler, and in some ways more profound. It makes the invisible actor show its root. Not just, radiation is here. Here is where it went. Here is how it moved. Here is the exact line where empty space was not empty at all. With that, whole arguments change. A charged particle is no longer just a number on an instrument. It has behavior, curvature, direction, density, a trail that can be studied frame by frame. The chamber turns events too fast for the eye into evidence slow enough for science. It teaches the invisible to write. Later generations inherit more than a result. They inherit a way of seeing. That connects directly to the larger question here. Hard-won knowledge often vanishes because it never got a trace the public could hold on to. Wilson solved that for a whole realm of physics. He gave the invisible a signature. Others push that gift further. Cosmic rays begin leaving marks in chambers instead of vanishing overhead as rumor from the sky. Then comes the next leap, timing. Random expansions waste film because most photographs capture nothing. So physicists like Patrick Blackett and Giuseppe Occhialini rig counters to trigger the chamber only when a particle actually arrives. Suddenly the particle is, in effect, taking its own photograph. Blackett later described a setup that captured a cosmic ray track on about 80% of photographs. 8 out of 10 frames, not blind luck, selection. The invisible is now visible and catchable. Once it becomes catchable, it starts giving up secrets nobody had names for yet. August 2nd, 1932. Carl Anderson photographs a track in a cloud chamber that becomes the first clearly identified positron, the positive electron. Not science fiction, not speculation. A line in vapor, a curve in a magnetic field. Antimatter, announced by a white thread in a box. So yes, Wilson wins the Nobel Prize in 1927, shared with Arthur H. Compton, for making the paths of electrically charged particles visible by vapor condensation. That is the official wording. It is accurate. It is also too small for what happened. The cloud chamber did more than detect radiation. It changed the status of the invisible. It took phenomena that could vanish into equations and forced them into images. It made knowledge portable, teachable, persuasive. Inventions like this end up in a strange category. They do not disappear because they were fake. They fade from public memory because they worked so well that their descendants replaced them, and the original miracle became background. The box on the bench is forgotten. The worldview it unlocked stays. Wilson climbed a mountain to understand a halo in mist. He came back with a machine that let matter betray itself in air. The first version was born from weather. What it finally exposed was hidden traffic moving through the world all along. For his method of making the paths of electrically charged particles visible by condensation of vapor. Number 5. Geiger Muller counter. In July 1928, a thin paper appears in Physikalische Zeitschrift, pages 839 to 840, with two names at the top, Hans Geiger and Walther Muller. You are in Kiel, in a physics institute room that smells faintly of hot dust, sealing wax, and ozone. On the bench, there is almost nothing to see. A tube, metal at one end, a wire down the center, gas trapped inside, a circuit beside it. That is all. No cloud bloom, no silvered photograph, no visible track, but the paper on the desk says the invisible has changed form again. Geiger is not starting from zero. 20 years earlier, in Manchester, in 1908, he spent nights in Ernest Rutherford's laboratory doing physics the hard way. No sound, no automatic record, just a zinc sulfide screen in darkness and a microscope pressed to the eye, while alpha particles arrived as tiny, dying flashes. 1, 2, 3, then doubt. Was that a flash or fatigue? Was that a particle or a pulse in the blood vessels of your own eye? Geiger and Ernest Marsden counted them anyway, hour after hour, while alpha particles struck thin metal foils. The numbers came slowly, painfully. In 1911, Rutherford used scattering like that to argue for the nuclear atom. In the room in Kiel, none of that patient strain is visible. What remains is the next answer. Stop watching for light. Make the particle announce itself electrically. Mumler works the apparatus. He is Geiger's doctoral student, young enough to rebuild the idea with less reverence for the old pain. The tube is sealed now, not an exposed arrangement on a bench, but a finished body, a gas-filled chamber with an electrode geometry set to do one very specific thing: wait. Then overreact. A single ionizing particle passes through the gas and tears electrons free. Under high voltage, those electrons do not drift politely to the wire. They accelerate. They strike other atoms. They free more charge. The event multiplies in a rush. An avalanche in a space no wider than a finger. One invisible intrusion becomes one full discharge. One discharge becomes one pulse in the circuit. One pulse can become a needle jump, or a lamp, or later the sound everybody will know as the Geiger click. Not radiation speaking. Electronics translating a discharge into something human nerves cannot ignore. You stand close enough to hear the room before you hear the instrument. The faint hum of power, a chair leg scraping tile, paper shifted by a sleeve. Then the source is brought near the tube. Maybe a small preparation in a holder, handled carefully, not theatrically. There is no glow around it, no cinematic aura. The tube looks dead. Then the circuit breaks the silence with a single dry tick, then another, then a rough little rhythm. Not music, not evidence you can see. Just a sequence of impacts from a world your senses never evolved to notice. Much gets lost in that translation. Alpha, beta, gamma, X-ray, to the tube. Any one of them can become essentially the same event if it ionizes the gas. The pulse does not carry a portrait of its source. It is yes or no, hit or no hit. Something came through. Something altered the gas. The machine turns the unseen into a count, but strips away identity on the way. That limitation is already sitting on the bench beside the Triumph, even if nobody in the room says it aloud. Mumler adjusts the setup again. Geiger watches. The avalanche has to stop after each pulse, or the tube will simply keep conducting and tell you nothing at all. So the gas mixture matters. An inert fill gas to be ionized, a quench gas to kill the discharge once it has done its job. Trigger, flash through the gas, collapse, reset, ready again. The point is not only to detect the event, but to survive it and wait for the next one. The timing is brutal. Dead time can run through tens or hundreds of microseconds, sometimes toward a millisecond, depending on tube and electronics. During that blink, the instrument is deaf. In a modest field, no problem. In a violent one, the clicks can lie by thinning out. The tube undercounts because the world is arriving faster than the mechanism can recover. In that room, in that moment, one fact matters most. A particle no longer needs a darkened lab, a trained eye, and heroic patience. It can strike a portable chamber and force out a pulse. The invisible has gone from flash to track to tally. And a tally travels. It can leave the institute. It can sit in a hand. It can move through streets. The scene shifts to another document, another emergency, another table covered in gear. March 2011, Japan. After Fukushima, volunteers begin assembling Geiger-type instruments with GPS units and open maps. You are in a car now, not a university laboratory. The dashboard rattles. Power lines pass overhead. A laptop glows in the passenger seat. The The instrument is mounted and alive, feeding clicks into a world that has already been told, in averages and official zones and broad statements, what is safe. But the road has its own opinion. You roll one block, the count rises. You turn a corner, it falls. You stop beside a gutter, and it jumps again. No cloud chamber can do this from a moving vehicle. No scintillation counting through a microscope can do this at all. Here the old 1928 logic is doing exactly what the paper on the desk in Kiel promised. One ionizing event, one pulse. One pulse, one data point. One data point, a mapped street. The clicks come faster now, stitching themselves into a rough fabric of place. School fence, side street, parking lot, ditch, playground edge. Not an abstract plume, not a citywide average, a patchwork, house by house, meter by meter. The car slows near an intersection. The person in the passenger seat looks from the instrument to the map and back again. Another cluster appears where the line should have stayed calm. The clicks harden into a rattle, then thin, then rise once more as the wheels cross into the next block. Someone marks the location. Nobody says much. The instrument does the talking now. Its message is simple enough to fit inside a sealed tube, and dangerous enough to redraw the street before your eyes. Up ahead, the road curves past a schoolyard. The count starts climbing before the car reaches the gate. Number 4. Starlight Scope Night Vision Device. On January 27, 1967, Major General William R. Pierce signed a U.S. Army Lessons Learned report on Vietnam. It described something soldiers had already started to grasp 13 months earlier, in December 1965. The jungle at night had changed, not because darkness disappeared, but because one side could now look into it without giving itself away. To see what that meant, follow one man carrying it. You are a U.S. infantryman on a wet night in Vietnam. An AN/PVS-2 Starlight scope is strapped to your weapon. The tube is 17.5 inches long. It weighs 6 pounds of metal and glass. It has 4-power magnification and a 10.7-degree field of view. Those are technical details in a manual. In the field, they mean a long, awkward weight hanging off a rifle while the jungle sweats on you from every side. It can fit on an M14, an M16, or XM16E1, even an M60. Men mounted versions on heavier weapons too. If this thing worked, it did what older night gear could not. It did not need to shine a beam. Earlier infrared sights could help in darkness, but they needed an active illuminator. Useful, yes. Dangerous too. If the other side had the right detector, your invisible flashlight was not invisible at all. The Starlight scope was different. The Army manual said it plainly. It projected no visible or infrared light. It took what was already there, moonlight, starlight, the faint scraps of night, and intensified them into a green image at the eyepiece. No searchlight, no glowing cone, no obvious signal saying, "Here I am." Picture that soldier stopping at the edge of a tree line and raising the rifle. To the naked eye, nothing changes. The jungle ahead is still a wall. Inside the scope, shapes start to separate. A path, a berm, the blacker black of a body against brush. He is not pouring light into the trees. He is pulling an image out of them. In a war where movement after dark had belonged to the side that vanished fastest, that was a change in who owned the night. The Army recognized it quickly. The January 1967 report says American forces had realized this new night combat capability back in December 1965, with the first generation of passive night vision devices. That wording matters because the chronology gets messy. Many later accounts place the AN/PVS-2 itself around 1967, but soldiers and officers were already using Starlight Scope as a family name for passive night sights before the standard individual weapon version settled in. The label blurred. The effect did not. By the time the PVS-2 became the familiar version, the miracle had a shape, a battery, and a price. BA1100 power cell, 6.75 volts, about 100 hours of use, and $1,350 per unit in Army equipment references. In 1960s money, that was not casual kit. It was an investment in asymmetry. This story is about asymmetry, not seeing more, seeing while staying unseen. The device belongs in a history of forbidden inventions for a simple reason. It crossed a line old battlefields had enforced for centuries. Darkness used to level things. It hid the weak from the strong, and the strong from the weak. Now one soldier could kneel in silence, look through a passive tube, and read terrain the other man still experienced as pure black. Knowledge that once arrived at dawn had been dragged back into midnight. But the miracle was never clean. The same manuals that sold the promise also listed the humiliations. Rain on the objective lens could degrade the image. Fog could smear it. Bright light could damage performance. Prolonged viewing through the scope could impair the user's own dark adaptation. The 1967 report was specific enough to be unsettling. A pilot should not use one before landing an aircraft. The machine gave you a second kind of sight, then punished the first one you were born with. Go back to that infantryman. He has been staring through the eyepiece too long. One eye lives in intensified green. The other stays in ordinary night. He lowers the rifle. The world outside the tube does not come back properly. For a few moments, the dark is worse than before. The device that made the unseen visible has made the visible less usable. Triumphal histories of military technology like clean upgrades. This was not one. It was a bargain, and bargains have a cost. There was another cost, quieter still. Later Army maintenance manuals carried a radiation warning for some units. Certain optical glass components could contain thorium-232. Modified scopes were marked with a green knurled ring near the eye shield to identify the safer version. It is a small detail, buried in maintenance language, but it changes the feel of the object in your hands. This is not just a tube and battery. It is a Cold War artifact in the most literal sense. Powerful, ingenious, field practical, and carrying a hidden hazard in the glass inches from a soldier's face. That man in the jungle is enough to explain the whole machine. He did not need to understand electron multiplication or image intensification theory. He needed to know whether the dark shape at 150 yards was a stump or a person. He needed to know whether the trail ahead was empty or occupied. He needed to know before the other man knew he had been seen. That is why the Starlight scope mattered so much in Vietnam. It compressed generations of optical research into one immediate battlefield fact. One trigger finger now had information the other did not. Hard-won knowledge that takes generations to master can disappear without leaving a visible trace. Some knowledge is too valuable to stay public for long. It gets classified, folded into doctrine, renamed, upgraded, and absorbed until the breakthrough vanishes inside routine equipment. The wonder drains out of it. The edge does not. Officially, the Starlight scope was a night vision sight. 4 power, 6 pounds, battery-powered, standard issue enough to sit in a manual. On the ground, in Vietnam, it was harsher than that. A way to turn darkness itself into a one-sided source of information, while pretending the night had stayed the same. Number 3. Ground-penetrating radar. On May 27, 2021, in Kamloops, British Columbia, Chief Roseanne Casimir stood before cameras and announced that a ground-penetrating radar survey at the former Kamloops Indian residential school site had identified what the community described as the remains of 215 children. The headline hit like a revelation. A machine had scanned below the surface and found the dead. The machine does something narrower than that. Start with the pulse. Ground-penetrating radar sends short bursts of radio energy into the Earth, usually between about 40 and 1,500 megahertz, depending on the system and the job. The pulse moves downward until it hits a boundary where the ground changes. Packed soil to disturbed fill, dry sand to wet clay, empty void to solid rock, pipe to dirt, grave shaft to undisturbed earth. Part of that energy reflects back. An antenna catches the return. A computer converts travel time and signal strength into bands, arcs, and broken shapes. It does not see bones. It does not produce an underground photograph. It detects contrast. That correction sounds small. It is not. In Kamloops, the radar was not peering into the soil and counting skeletons one by one. It was registering anomalies, places where the electrical properties of the ground did not match what surrounded them. Disturbed shapes, repeated patterns, targets of interest. Here, that distinction mattered. On July 15, 2021, anthropologist Sarah Beaulieu publicly narrowed the language. Not confirmed remains, not excavated graves, roughly 200 targets of interest, likely associated with burials, identified through the survey. She stood in front of microphones and replaced a headline with technical terms. The second statement was colder. It was also more precise. The distance between those two statements is where ground-penetrating radar actually lives. Strip away the mythology and look at the evidence piece by piece. First, the signal itself. Radio frequency pulses. Nothing mystical. Second, the target. Not an object, but a difference. GPR is blind to meaning. A trench, a void, a utility line, a rock boundary, a grave shaft, to the machine, all of them begin as contrasts in subsurface properties. Third, the image. What appears on the screen is an interpretation assembled from reflected energy, not a direct view through the Earth. When people say the machine found 215 bodies, they skip the hardest part of the process, interpretation. Operators obsess over soil for a reason. Wet ground can ruin a survey. Clay-rich ground can swallow the signal. Salty ground can attenuate it so aggressively that depth disappears fast. In friendly conditions, radar can reveal layers, disturbances, and buried features with eerie clarity. In hostile conditions, it gives you noise, shadows, and false confidence. The machine is only as honest as the ground allows. There is nothing cinematic about that. No magic beam, no X-ray vision, just pulse, reflection, attenuation, judgment. That judgment is what gives the tool its force. A pattern of anomalies in the right place is not random. At a former school site, where historical testimony, records, and community memory already point in one direction, repeated grave-like disturbances carry weight. They are not final proof by themselves. They are enough to alter headlines, public memory, and government response. The machine can make the hidden visible enough to change history, but not visible enough to end doubt by itself. Its paper trail is older than most people realize. In 1910, two German inventors, Gotthelf Leimbach and Heinrich Loewe, filed patent DE 237944 for using radar-like methods to locate buried objects. The idea appeared early. Send energy into a hidden space, read what comes back. By 1929, W. Stern was using related radar methods to measure glacier depth in Austria. Not graves, ice. The logic was the same. The unseen could be reached if it reflected. The popular story says this is a machine that reveals what lies underground. The record says something narrower and stranger. It reveals boundaries, interfaces, interruptions, places where one material history cuts into another. That is why trained interpretation matters so much. A clean-looking anomaly does not explain itself. Its shape matters. Its depth matters. Its repetition matters. Its relationship to known site features matters. Crosslines matter. Survey design matters. Frequency choice matters because higher frequencies give sharper resolution but less penetration, while lower frequencies go deeper but lose detail. Every dramatic image depends on dozens of quiet, technical decisions made before the antenna ever touches the ground. That also explains the other sense in which ground-penetrating radar is forbidden. Not because it sees too much in some supernatural way, because it is a radio transmitter. In the United States, GPR and wall imaging systems fall under ultra-wideband rules in FCC Part 15, with permitted uses tied to law enforcement, firefighting, rescue, scientific research, mining, and construction. The invisible eye is regulated because it broadcasts into the world. So even here, with a machine built to uncover hidden things, access narrows. Certain operators, certain purposes, certain settings. The public myth is unrestricted vision. The actual device comes with conditions, limits, and interference rules. That is the forensic picture. In cam loops, the machine did not exhume anyone. It did not settle every claim. It did not deliver the certainty people wanted from the first headline. It did something almost as consequential. It marked the ground with enough consistency, in a place with enough history, that the absence below the grass could no longer be treated as empty. You are standing on a field that looks flat, ordinary, finished, wind over grass, trees at the edge. Nothing moves. Then, an antenna passes over the surface, and the screen fills with faint bands and buried interruptions. Not faces, not names. Repeated breaks in the soil where the earth no longer matches itself. The field stays quiet. The pattern does not. Number 2. Through-wall radar. On December 30th, 2014, the 10th Circuit published an opinion in United States v. Denson. It took a fugitive arrest in Wichita, Kansas, and made it much bigger. Not because of the guns officers found inside, not because of the warrant they already had for Stephen J. Denson. It was because of a device buried in the facts, about 10 by 4 by 10 inches, small enough to hold in one hand, precise enough to tell police whether someone on the other side of a house wall was moving or simply breathing. Start with the time. Around 8:30 a.m., a winter weekday, officers arrive at a residence tied to Denson. They have a name on the utility account. They have no alternate address for him. They see signs the electricity is being used. They know he is unemployed. The inference is simple. He is probably inside. That part is ordinary. Then they raise a radar unit outside the home and point it at the structure. The machine did not give them a photograph. That matters. Many of these systems do not. See-through walls sounds like X-ray vision. The actual readout is narrower and stranger. Motion, range, presence. A human body reduced to signal return. In older military descriptions, sometimes just a moving colored blob. In the Wichita case, the opinion says the Doppler radar revealed someone inside by detecting movement consistent with breathing. Not identity, not intent, respiration. Now put the numbers next to the constitutional problem. In 2001, in Kylo versus United States, the Supreme Court said police could not use thermal imaging to scan a home without a warrant. Heat leaking from a house was enough to trigger Fourth Amendment protection. In Wichita, officers used radio waves to detect life through a wall before they entered. The 10th Circuit upheld the arrest anyway, because the government had enough other evidence to justify entry. So the central issue stayed untouched. Judge Neil Gorsuch said it plainly. Warrantless use of such a device raised grave Fourth Amendment questions. Not minor ones, grave ones. But the court did not decide them. A machine reached through the legal shell of a home, and the precedent did not catch up. The hardware had been heading there for years. In October 2007, the National Institute of Justice described DARPA-backed through-the-wall systems in language that sounded almost clinical. One handheld device, radarscope, could detect people through 12 inches of concrete and out to 50 feet beyond. Another, larger system called Soldier Vision could sense as far as 60 feet into a room while standing 30 feet off from the wall. Those are not laboratory inches. That is hallway distance, front yard distance, street distance. Because the technology was real, the regulations were real too. Under 47 CFR Section 15.510, certain wall imaging systems operate in an ultra-wideband range from 1.99 to 10.6 gigahertz. That is an enormous slice of spectrum, wide enough that the FCC did not treat these devices like toys or hobby electronics. The rules require a conspicuous restriction label: law enforcement, emergency rescue, firefighter personnel. Those are the named users, not consumers, not curiosity buyers, not the neighbor with too much free time. The public version of the invention was always a little misleading. It was never, everyone gets to see the unseen. It was specific institutions transmitting through your wall under specific rules. In 2014, the same year the Denson opinion came out, NIJ-backed testing examined 4 law enforcement through-wall systems side by side: Range-R, Xaver 100, Xaver 400, and Aquila Aster. 4 devices, 4 different ways of reducing a room to returns. Some focused on whether someone was moving, some gave more positional data, some worked at short range, some at more of a standoff. The Aquila Aster report put one figure on that distance: up to 98 feet from the target building. 98 feet. Not pressed against the siding with your ear to the wall. Across a yard. Across a narrow street. Far enough that the person inside may never know the scan happened at all. But the numbers cut both ways, because through-wall radar is not magic. Metal walls can block it. Metal-backed insulation can distort it. Metallic barriers can kill the signal or produce nonsense. The myth gets cleaner as the engineering gets messier. A drywall interior in one building is not reinforced concrete in another. Human stillness matters. Sensor placement matters. Standoff distance matters. Frequency matters. The same trade-off appears again and again. More detail usually means less penetration. More penetration usually means less detail. So no, this is not a perfect eye. It is a probabilistic instrument. It takes a hidden body and turns it into an inference. That is why the Wichita case lands so hard. Officers did not need cinematic certainty. They needed enough confidence to cross a threshold. Enough signal to convert probably inside into go in. The machine did not have to see everything. It only had to see enough. Once just enough exists, the old boundary starts to look fragile. For generations, the wall of a house did more than keep out weather. It separated what the street could know from what the room could conceal. Sound leaked, heat leaked, light leaked if curtains were open. But breathing behind plaster belonged to the interior. Then, a handheld box, roughly the size of a lunch container, reached across that line and sent life signs back to the state. The larger loop tightens here. Hard-won knowledge does not always vanish because it fails. Sometimes it disappears into restricted labels, procurement channels, and unresolved case law. The public hears through-wall radar and imagines science fiction. Agencies get the field manuals. Courts get the edge cases. Everyone else gets silence. You can feel the tempo shift there. This is not a rescue team in earthquake rubble, not a firefighter checking a smoke-filled room. Those uses are real. They are the first examples defenders reach for because they are the cleanest cases. But the same frequencies, the same Doppler logic, the same wall penetration move easily from saving trapped bodies to locating wanted ones. Same box, same pulses, different threshold. So go back to Wichita, 8:30 a.m. Utility records, no alternate address, electricity in use, a handheld radar outside a home. Officers enter. Denson is there. Firearms are there. The conviction stands. The constitutional question does not. Zero ruling on whether sensing a man's breathing through his wall without a warrant was lawful. Number 1. Synthetic aperture radar. In 1951, at Goodyear Aircraft in Arizona, mathematician Carl Wiley was staring at a reconnaissance problem with a ridiculous price tag. If you wanted radar sharp enough to separate roads from riverbanks and ridgelines from runways, a normal system pushed you toward an antenna about the size of a football field. That might work on a drawing board. It was useless under an airplane. So Wiley flipped the problem. Do not make the antenna bigger. Move the aircraft. Collect the tiny Doppler changes from each patch of ground. Let time stack those echoes into something that behaves like one enormous aperture. Motion became the lens. Distance became hardware. Computation became the part nobody on the ground could see. Make that concrete. A plane passes over you once. There is no giant dish, no impossible wing load, no camera view through cloud or darkness. But the path of that aircraft, seconds of travel, repeated pulses, return after return, is rebuilt into an image detailed enough to sort one kind of terrain from another. The machine did not stare longer through glass. It remembered where it had been. It turned that travel into a virtual antenna, hundreds or thousands of times larger than the metal bolted to its body. If that works, concealment changes. Night gets weaker, weather gets weaker, camouflage gets weaker. A country can hide a facility from pilots and satellites with cloud, smoke, jungle canopy, or darkness. It cannot easily hide from a sensor that makes its own geometry as it moves. The mechanism matters because this is where the line moves. Through-wall radar only needed enough confidence to tell operators that someone was probably inside. Synthetic aperture radar reached for more. Shape, texture, surface, pattern. It asked whether the world itself could be reconstructed from echoes. When that works, the old idea of unseen starts to collapse. Wiley's concept did not arrive as a public miracle. It went where many of these inventions go first, into military need, patents, and classified development. On August 13, 1954, he filed what became U.S. Patent 3,196,436, Pulsed Doppler Radar Methods and Apparatus. It was not published until July 20, 1965. By then, the Cold War had already made the stakes obvious. Maps were power. Terrain was power. The ability to read the ground without waiting for clear skies was power. Hard-won knowledge does not always disappear. Sometimes it narrows. It passes into programs, acronyms, and restricted rooms, while the public sees a softened civilian version years later. That civilian version arrived on June 28, 1978, when NASA launched CSAT. It stayed alive for just 106 days, but that was enough to prove something huge. The satellite carried 5 instruments: a synthetic aperture radar, radar altimeter, scatterometer, microwave radiometer, and a visible and infrared radiometer. One of them could do what ordinary cameras could not. It could read the ocean through cloud cover, surface roughness, sea ice, the texture of water shaped by wind. The trick was the same one Wiley had sketched back in Arizona. The sensor moved, the echoes shifted, the path became part of the instrument. This was not simply better radar. It was radar using time as structure. CSAT only hints at the jump because Earth still gives you an optical fallback. If the clouds clear, cameras can work. Venus does not give you that mercy. On May 4, 1989, Space Shuttle Atlantis carried a 7,604-pound spacecraft into orbit. The next day, the crew deployed it. Its name was Magellan. Here, the story stops sounding like reconnaissance engineering and starts sounding like trespass. Venus is wrapped in clouds so dense that ordinary cameras do not get a surface portrait. They get a blank. For centuries, that planet kept its face. We could measure its orbit. We could estimate its heat. We could guess. But guesswork is not a map. On August 10, 1990, Magellan slipped into orbit around Venus. Each orbit took 3 hours and 9 minutes. On September 15th, it began its first mapping cycle. Picture that scene. You are circling a planet whose ground no human eye can see. Below are mountains, craters, lava channels, volcanic domes, plains crushed and folded by forces no telescope can photograph through that cloud deck. So you do not wait for visibility. You fire radar, pulse after pulse. Orbit after orbit, echo after echo. From those returns, the invisible surface begins to appear. By May 15, 1991, Magellan had mapped about 84% of Venus. Not sampled, not hinted at, mapped. Volcanoes, impact craters, vast lava flows, pancake domes, hundreds of times wider than a city block, flattened across the landscape like something poured and frozen under alien pressure. An entire world translated from radio reflections. Magellan did it with essentially one main scientific instrument, its SAR system. One instrument, but not one kind of knowledge. The same echoes supported imaging, altimetry, and measurements of surface properties. That is what makes synthetic aperture radar feel almost unfair. It does not merely look, it extracts. It keeps taking from the same return. If the claim at the start is true, if motion plus processing can turn a small antenna into a giant virtual eye, the consequences are much bigger than one clever radar mode. You do not need direct sight to build a picture. You need passage, timing, and enough compute to make memory behave like hardware. That applies to spy planes over contested borders. It applies to satellites over oceans. It applies to planets hidden beneath permanent cloud. It also points somewhere less comfortable. Once a state learns to reconstruct the unseen from echoes, every improvement in orbit, processing power, and revisit rate chips away at the excuse that something remained hidden because no one could physically look at it. There is one more turn here. Synthetic aperture radar is often introduced as a seeing technology. That undersells it. Cameras depend on light already present or reflected in visible wavelengths. SAR brings its own illumination, writes its own angle, and builds the image after the fact. It does not wait for the world to reveal itself on natural terms. It forces a reply. Through-wall systems cross the boundary of the house. SAR crossed the boundary of visibility itself. Not by making a bigger eye, but by proving you may not need an eye at all. NASA's own summary of Magellan's first results put it plainly. An entire planet has emerged from the darkness.